What up, guys? We're doing this triangle congruency practice problems. Let's hop right into it. So one of the first things we're going to be doing here is reading what are called congruency statements. That's what this is. This guy is called a congruency statement. What the congruency statement says is, in this case, is that these two shapes, these two triangles, are identical to each other. So because the two triangles are identical to each other, every single individual part is identical to each other. So in this case, we have a triangle KJI is congruent to triangle KJF. Because I is in the third position here, and F is in the third position, those two angles must be the same. So angle I is congruent to angle F, and that is the entire problem. After that, where this time is talking about a segment or a side of the triangle. On the side of the triangle there, if you have RS being the second two letters, well, the second two letters, it's the second and third letter. Second and third letter, WS is also the second and third letter, and therefore the answer to this question. One thing I want to pause really quick and let you know is the best way to do these is to actually attempt them on your own first and then listen to me afterwards. So if you already were copying for those first two, maybe hit that pause button, try those two questions out on your own. Once you've tried them out on your own, then you can go ahead and tell me, hey, I got them right. Feeling good. JC's our correct answer on this one because JK's first two, JC's first two, angle V in the middle, angle G in the middle. Boom, boom, boom. We're done with this one. Question number 5. So question number 5 is talking about actually marking up the triangles. So when you're marking up the triangles, how are we going to mark these things up? So we have to make sure that they're showing that these triangles are the same. To show the triangles are the same, we're going to start with the angles. I personally recommend starting with the angles in the order that they're written. So this is the R angle. So I'm going to put a single marking on the R there. When I do my angles, I like to do tick marks instead of number of arcs, but I'm going to show both this way and the other way for question 6. And then I'm going to do only the arcs because that's how the papers have been doing it. So anyways, so angle R is the first one on both of these. We actually knew these were the same in advance because they're vertical angles. But the other ones we didn't know were in advance. But we have the angle Q and the angle L. So those two are the same because they're in the second spot. So we're going to go to angle 2. Tick marks there for angle Q. And for angle L, also getting 2 tick marks. And again, because they're in the second position. The third one, guess what? Gets 3 tick marks. Wow. How special. And there you have it. After that, we need to mark the sides up too. So we did the angles first, and now we need to do the sides. So for the sides, same exact idea. RQ are the first 2 letters, so we're going to put 1 tick mark there. RL, first 2 letters, 1 tick mark there. And then QP, the second and third letter, get 2 tick marks. LK, 2 tick marks. There's only one side left that gets 3 tick marks. Beautiful. Next up, LMK is congruent to TKV. I wonder, like, so it's like right there. I wonder if my camera maybe like not flat. I don't know. I don't know, guys. I don't know. I'm gonna like it like passes the focus point, you know? I wonder why it does that. Whatever. I'm just gonna move on. So the first position there. So like I said last time, I'm gonna do this with the number of arcs instead of tick marks for the angles only. So we got 1 arc for L and for T. We're gonna have 2 arcs for M and for K, and then 3 marks for this K. 3 marks for this V. So you can have triple arcs instead. That's the other way of doing it. Both of these are correct. This is the way the book's been doing it, so I think that's the way I should continue doing it. But this is how I learned as a kid, so I don't know. Doesn't really matter either way. LM are the first 2 there. TK the first 2 there. MK the next 2. And then KV, the ones after that, and then we have triple tick marks there, triple tick marks there. I think it's a little bit hard with these ones. It's like they're so big, you know. I don't know. Whatever. All right, number 7 here, JIH is congruent to HBC. So we have the J, we have the H, we have the I, we have the B, and we have the H, and we have the C. And because they're like in the same spot, basically bottom left, top, bottom right, I think it's going to be really, really fast to do these tick marks. 1 there, 1 there, 2 there, 2 there, 1, 2, 3, 1, 2, 3. Nice. And then BAC, congruent to FGC, we have angle B and angle F. We have angle A and angle G. And then we have angle C and angle C. So both of these get the triples. BA gets 1 tick mark. FG gets 1 tick mark. AC gets 2 tick marks. GC gets 2 tick marks. We only have 1 side left. Very nice. We're moving on to that next page. Let's do it. These are exactly the same concept, except backwards. Because now they've done all those markings for you. Like I said, they have those little triple arcs down there. But now we have to actually write that congruency statement. So we're going to start with a triangle. And then I recommend going by the angles. So just like the last one, we started with the angles. We're going to do the angles here. We have 1 tick mark, 1 arc, 2 arcs, 3 arcs. 1, 2, 3. X, J, L is congruent to, and that congruency symbol has an equal sign with a little swirly on top called a tilde. We're going to continue on. We got another triangle there, and we have a 1, 2, 3. X, W, V. Boom. Number 10. So on number 10 here, same ideas. Starting off with a triangle. 1, 2, 3. RQP. RQP congruent to RQL. Continuing on to question number 11. So on question number 11 here, this one looks a little bit crazy, but this is one triangle here. We have triangle SRK for the 1, 2, 3. And on this one, we have 1, 2, 3. Triangle MLK. We got the Martin Luther King one. And there we go. Question number 12. Same exact idea. Triangle QRS is congruent to 1, 2, 3, 1, 2, 3. Triangle SML. Boom. All right. So on this next one, these ones are a little bit obnoxious, a little bit annoying, but we're going to get through them. 2 triangles are congruent. If they are, state how. The only ones we're going to be able to do for the first part of this page, the only postulates you're going to learn here are going to be angle, side, angle, 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 side, side, angle, side, and side, side, side. The first thing to notice about all of these is the letters there have at least 1 letter S for every single question. So because they have at least 1 letter S for every question, the only way 2 triangles can ever be the same is at least one of their sides is known to be the same. Either like questions 13 and 14, where they share a side, so they have to be the same, or questions like maybe number 17 or 18, where they have a side that's marked to be the same. So right away on question number 15, if you notice, there are no sides marked anywhere. Because there's no sides marked anywhere on number 15, we can write a say not enough information for this one. Or the answer is just no. All the other ones, it turns out there is enough information to actually do that. What you're going to want to do on questions that are asking about congruency like this, where you don't know if they're congruent or not, you're going to put this little symbol next to each one of the markings. So there's no marking over here right where I'm pointing. So because there's no marking right there, that means you're not going to put anything. But there is a marking here, the letter A. There's going to be another letter A, and then another letter A, and then another letter A, and we're skipping all the ones that don't have markings. In addition, we have a side that's shared by a triangle. Anytime those sides are shared, you put a little circle. That little circle is called the reflexive circle. And it lets you know that a side is shared. That's what that says, that little circle. So because the side is shared, we can put a little s. And if you notice, we are in a situation where if we started with that very first angle, we'd have 1, 2, 3. We'd have an angle, and a side, and that is going to be a yes by angle, side. Students will often ask, how come the S didn't go in the middle? Well, the S doesn't go in the middle on this one because the side is not in between the two angles like it is on question 14. On question 14, I'm going to have that little circle again because it's shared side, and then I'm going to put an angle, and then an angle, and then an angle, and then an angle, and then a side, and then a side. And if you notice, it lines up nice and neat. ASA. On number 16, you might notice that it's exactly the same concept as number 14, where we have those angles that are shared, and we have that side in the middle. So again, this one's going to be a yes by ASA. Ah. Check out number 17. On number 17, if you notice, none of the angles are marked. It's just sides everywhere. Because it's just sides everywhere, the answer is yes by side, side, side. Question number 18. So on question number 18, we have an angle here, we have an angle here, we have a side marking here, we have an angle here, we have an angle here, we have a side marking here. If you notice, we have an angle, and then a side. That's going to be a yes by angle, side. Boom. Moving on to the back side here. Number 19 is a special question. Anytime you have a right angle, you have a special postulate you can use called HL. This stands for hypotenuse leg. In the event that you have a right angle, which we do here, we have our right angle box. The sides that it touches are called legs. Leg. That's also a leg over there. And that longest side that's shared is called the hypotenuse. Please note, on some triangles, the hypotenuse is not shared, like over here. The sides are not shared, and instead it's the leg that's shared. So both of these here are going to be yes by hypotenuse leg. On number 20, we can put the little marking there in the middle that they're the same, but you'll notice that, hey, it's going to be a yes by side, side, side. Couldn't even see it. My bad there, guys. But number 21 is a special case. The reason why 21 is a special case is we do have that shared side. We have an S, we have another S, we have an A, we have an A, we have another S. But if you notice, if we wrote it down, we'd have ASS. Oh no. ASS is a bad word, which makes it a bad postulate. So anytime you have an ASS, bad word, bad postulate, the answer is no, not enough information. We're almost done with this entire thing. Let's move on to the last couple of questions here. Question number 23. So on question number 23, it says find the length indicated. The idea is that anytime you have these markings that show that these are exactly cut in half, these two are like HG is cut in half exactly, and FG is cut in half exactly, this middle line is called the mid-segment. Mid-segment. And mid-segment is half the other side. Because it's half the other side, look how easy this question is. 18 divided by 2 is 9. Done. All right, wow. Same thing with number 24. 12 divided by 2 is 6. Amazing. We're done. All right, moving on. Number 25, much more interesting. It's the same exact problem, but this time we have those X's. Because we have those X's, we're going to go ahead and try to make it so we can understand what's going on. To do that, because we have that idea that the half of that longer side, half of the PR here is going to be equal to DC. The better way of writing that is to put the DC part first and just say 2 times the DC is going to be the PR. So 2 times this length is this length. To make this happen for us, we're going to do 2 parentheses 2x minus 12 is equal to x plus 6. What that's going to do is a distributive property. 2 is going to be multiplied to here and to here. That's going to give us 4x minus 24 equal to x plus 6 Please be careful. In class, oftentimes students will forget that negative sign. They'll forget to multiply that second one by 2. When we're doing this, we're just doing that regular old switcheroo thing. We're going to move that x to the other side. 4 minus 1 is 3. 24 plus 6 is 30. Divide both sides by 3, and you will get x is equal to 10. For that very last step, it says to find PR. So PR is going to be equal to 10 plus 6, because we're using that x right there. Oftentimes it goes in parentheses. I think it's a good idea to do that. 10 plus 6, and that's going to give us 16. Same exact idea on question number 26. So on question number 26, we're going to have 2 multiplied by 2x minus 13 is equal to 7 plus x. Take that 2, distribute it out. I wonder if, yeah, I'm just going to move this further over so it's like actually in focus. All right, moving here, going to both. We have 4x minus 26 is equal to 7 plus x. We're going to go ahead and do that switcheroo again. 4x minus x is equal to 7 plus 26. 4x minus x is 3x. 7 plus 26 is 33. Divide both sides by 3, and you get x is equal to 11. You're finding FG. FG is equal to 2 times 11 minus 13. 22 minus 13 is 9. Hopefully I didn't go too fast there. I just wanted to get done. I got a whole nother video to make after this one. I've got to admit, we already did one video today. We're on video number 2. We have a third one to go. Here we go. 27. Stated that 3 numbers can be the side of a triangle. The rules are going to be very, very straightforward. All you have to do is to figure out if the short plus the short is bigger than the long. By the way, one of those can end up being the same value. We're going to see what happens. So what is the two shorts? So 3 plus 8 greater than 12. Is 11 greater than 12? The answer is no. By the way, you're going to need that inequality on the actual test to get full credit, and that's all you have to do. So this next one, we have a 4 plus 12 greater than 12. Is 16 greater than 12? Yes. Wow. Wow. Super interesting stuff. Totally riveting. I can't believe how interesting these questions are. All right, 2 plus... No, it's my fault, by the way. I made this paper. So anyways, 2 plus 9 greater than 11. Is 11 greater than 11? Don't be tricked. The answer is no. And again, you need that original equation. Here we go. All right, two sides of the triangle have the following measures. Find the range of possible measures for the third side. So using the logic up here, if I just have like a random x value and trying to figure out which one's which, to figure out which can be, how big it can be, how small it can be, all you have to do is very straightforward. You add the numbers together and subtract them as well. 10 plus 10 is equal to 20. 10 minus 10 is equal to 0. So your final answer has to be between 0 and 20. 0 less than x less than 20. And that is the whole concept. Likewise on this one, I don't even think I need to show the work. 12 minus 11 is 1. 11 plus 12 is 23. Easy enough. If you need a longer lesson on any of this stuff, by the way, guys, you got to come into tutoring. Don't forget, I am kind of going through this in a way of like, oh yeah, you already saw this once, but maybe you didn't. Order the angles from smallest to largest. So if you notice that these two are the same value, so the angles they go with, by the way, are always the opposite side. So I'm going to draw the arrows. I was not really drawing the arrows in class because I was doing with more letters and stuff, but doing it the long style. But here's another way of seeing it, just in case that way in class wasn't making sense. So those are the same. So that means that these angles here, that the measure of angle C is equal to the measure of angle D. But because that 25 is bigger, that means that both of these are smaller than the measure of angle B. So in other words, this 18 goes with D, this 18 goes with C, that 25 goes with B. So 18, 18, 25, and there is our order. For question number 33, exactly that same concept. 14 is that smallest number. So 14 goes with this angle all the way on the other side there. So we can just go ahead and say that the measure of angle C is again the smallest, and that is going to be smaller than the measure of angle D, and that is over here with that 19 going across. And that very last side there is the measure of angle E. We only have 2 more questions all. 2 more. Question number 34. So question 34, first we got to figure out what this guy is right here. That's going to be 180 minus the other two, minus 53, minus 85. I remember from earlier today and doing it, it's going to be 42. Is that actually 42? I'm like 95% because I just did it in my head, but I'm like not thinking straight. So I'm going to double check. Got this 42. So 42 is the smallest value. So like 42, is less than 53, is less than 85. So talking about the angles there, that's what there is. But we're talking about the sides though. So 42, that's the angle D here. That goes with the side BC. So BC is less than, and then 53 is next. 53 goes with CD. And 85 goes with BD. Oof. Question number 35. So on question number 35, we got 63 for this last one right here. I just did 180 minus the other two, by the way. Same exact idea. 40 is the smallest. That goes with CB. 63 is next. That goes with AB. And last but not least, we have the 77 goes with AC. Have a wonderful rest of your day, guys, and peace out.